Okay, welcome. It is Miss Siddig, and this is my first video filmed in sort of the self-isolation that we are in right now. Classes at my school are postponed until after spring break at this point, and we are being asked to put together some optional lessons for students so that they have something to sort of keep themselves fresh before we go back to school, hopefully in April. So this video is graphing lines. If you have never watched one of my videos before, welcome. This is going to be a really basic review of how you graph a line in case you have forgotten how that works. If you are in my Algebra 1B or set to be in my Algebra 1B class, this is a good thing to review if you don't remember how to do it from before, either if you forgot from last quarter when you were taking 1A, or if you didn't take 1A last quarter and it's been a little while since you've done algebra. My setup has changed a little bit. I'm trying out some different things just to kind of see what works best so that I can record videos during this whole time. All right, so graphing lines. There's a couple of different ways that lines can be written, and there's different ways that they can be graphed. So I'm going to cover a couple of different ways. The first is if it's already in what's called slope-intercept form. The reason that it's called slope-intercept form is because math people, we are very not creative when it comes to naming things, which I think is good. I think the more names you have that describe exactly what you're doing, the better off you are. This is called the slope-intercept form because it literally gives you the slope and the y-intercept. All right, the number that is our multiplier of x, that's the rate of change or the slope, and I can do an exciting video about word problems at some point too that kind of deals with it. This is our per idea that, like for example, if you were being charged hourly, that would be a rate, and you know that it's a per because it's a multiplier. It's also our slope. I can do a video on how you find slope and all that sort of stuff too. Then this b at the end is our y-intercept. If the b is missing, it means that your intercept is 0. If your slope is missing, then that means you have a special line, okay? But let's go ahead and let's just start with the generic problem. I'm going to be sassy and I'm going to use a fraction for my slope, and that's okay. So I have the line y equals 1/2 x minus 3. I always like to identify my pieces first before I graph them because I'm a teacher and because I think it's good to make sure that you know the difference between the two. All right, remember our slope is always our m in our mx plus b. It is always attached directly to the x, and we don't need the x. The x is a variable and it's going to stay there. We only care about the number in front of that, which is 1/2. Okay, now I'm also going to label this in just a second because it's going to help me determine how my line is going to move. What a slope is it tells you the steepness of a line. So if you have a very low slope, your line might look like that. It's hard to see my full arm movement there, but if you have a very sharp slope, your line might look like that. And it could go positive, it could go negative, all sorts of exciting stuff. All right, the y-intercept is actually an ordered pair where the first number is always a 0 because you're on the y-axis, and on the y-axis you haven't gone anything in the x direction, so the x is always a 0, and then your intercept is the y value. All right. Normally when I'm graphing these, if the numbers aren't very big, I usually do between 5 to 7 tick marks in every direction. I also like to make sure to label my axes in case that I forget. I also want to be precise so that if somebody looks at this, they know what I'm doing, and they want to make sure I'm graphing in the XY coordinate because there are other coordinates systems that look like this. All right, now I begin with my B. So I'm going to plot my y-intercept first, which is at -3 on the y-axis. Negative, remember, is down here. Positive is up here. So I'm going to go 1, 2, 3, and they're not precise because, you know, I'm not graph paper and or a computer, but there is my y-intercept. Now we're going to move with the m, all right? And some people think of slope as rise over run, because that's the literal movement of it. Rise is always an up and down movement, so it's your y movement, how you're changing in the y direction. Run is always your X movement, how you're changing in the X direction. And so, like, you can't run until you rise. So you always have to rise and then run. When you count the slope, you can actually do either as long as you do both of them. And then what I like to do is I like to give a directional value next to it so that when I'm looking at it, I'm not sitting and trying to figure out, am I running forward? Am I running backward? Am I rising up or down? I have it listed here. So when it's a positive rise, rise is in the Y direction. Positive Y we said is up. So I'm going to rise 1 up. Positive run is in the right or the left I'm sorry. Sorry, I had a kid just come into like the corner of my eye, and so I got distracted. Run is positive is to the right, negative is to the left. So what I'm going to do is, because it's a positive run, I'm going to run forward or to the right. I shouldn't say forward, but I think of it as like a forward, like this is forward versus this is backward, which might be a little bit bad, but all right. So now here's the trick. From my intercept, I'm going to move. So I begin here and I move with M. I'm going to rise 1 and run 2. Now, the cool thing about slope is it goes on forever, so then I can rise 1 and run 2. Rise 1 and run 2. Now, if I wanted to see the points that were going the opposite direction, I would do the opposite 2 movements. So I would rise down 1 and run back 2, because -1 over -2 is equivalent to +1 over +2, because the negatives would reduce each other. So I can then rise down and run backwards again. And then I've got a really nice long line. Sometimes students get really caught up in drawing like the tiniest little piece of line that they can. And if all you're doing is graphing the line, that can be okay. But if you're trying to use the line to see, like to make a prediction, if you're trying to use the line to solve an equation, to solve a system, or even to solve an equation, like we were trying to figure out what X would make the Y 0 or something like that, it's really nice to have more of the line than less of the line. All right, so slope-intercept form. Y equals 1/2 X minus 3. We begin with our B, we move with our M, and that gives us our line. Now, here's how you know if you're not sure that you've drawn your line in the correct slope. This is how you tell. Your mathematician, whenever they're going to climb a line or climb any function, they always start at the left. So here's my little mathematician. She is very thorough, and the idea is, as she starts to the left, is she climbing uphill or downhill, right? When you look at her, she's climbing uphill, and then that makes sense because my slope is a positive slope, and a positive slope should climb uphill. I'm sorry, I have a visitor. Back up, little visitor. All right, so that's what happens when you homeschool and are at home. So that's how you graph a line with slope-intercept. Now, there are definitely other ways to graph lines because you're not always going to have a line set into slope-intercept. So another way to graph a line is just by using something simple like a T-chart, or you could even use a specialized T-chart to do like your X and your Y intercepts. So another method would be a T-chart. I like to do T-charts when it's more complicated than a line. But if it's a line, I usually like to use either slope-intercept form, or I like to use XY intercepts. But let's go ahead and let's do one where it maybe wouldn't work so nicely. So 2y equals 3x minus 4. Okay, I don't have any idea what this is going to look like because I have not plotted it. I just totally threw the numbers out. And this is a nice way. A T-chart is a really nice way to figure out what something is doing when you don't have an idea, right? I didn't even draw my coordinate system yet because I don't know what these numbers are going to look like, and I don't want to draw a nice small coordinate and find out that my numbers are all going to be really big or my numbers are going to be really far into the negative. So a T-chart is a nice way to do this so that you can just get a general idea. I really recommend it as you're taking more advanced math, because if you ever are trying to graph something you don't know what it looks like a logarithm, an exponential, an absolute value, even a quadratic, a cubic, anything that's bigger than a line, you can always default right back to a T-chart and it will work, as long as you calculate your math correctly. Now, this one, if you are watching me and you're like already a math person, you might be like, well, let's just divide everything by 2 and then it'll be in slope-intercept form. Very true, all right? Good points to you. Good job. But what I want is, I still just kind of want to do a T-chart just to see what's happening. I always like to pick a couple of negative numbers. I always like to pick 0 because I want to know what's going on at x equals 0. And then I pick a couple of positive x's because this gives me at least an idea of what's happening around the origin. And it gives me an idea of what the graph is doing in the negative x value and the positive x value. So it just gives me kind of a better sense. If you have a graphing calculator, you couldn't plug this into a graphing calculator the way that it is, which is why it's nice to know that you could divide by 2 and make it a y equals. But it also is a nice reason that it'd be like, oh, okay, let's solve it using our T-chart. All right, so I'm going to plug -2 in for the x. This is how your T-chart works. You replace your x value with the number that you chose. And you can choose any numbers. Those are just the numbers that I chose. Now, this is going to take me more algebra than what's going to fit in this space. So what I'm going to do is I'm going to do it up here. I'm going to get my answer, and then I'm going to erase my algebra. All right, because I'm on a tiny little board. If you're on paper, you can keep it. All right, so 3 times -2 is -6. I have 2y equals -6 minus 4. -6 minus 4 combined together through addition. You owe me 6 and you owe me 4. That gives me -10. I divide by 2, so y equals -5. So now I know I have an ordered pair, -2, -5. All right, now I'm going to do the same thing for the next piece. All right, I did the math there already, so I'm going to erase it. Goodbye, math. Now I'm going to do the next math there. This also is a good place where if you get an answer like that, you can always choose not to graph that, right? If you get a point and you're like, ooh, that's a decimal, or that's going to be difficult to graph, or I'm not sure how to put that on there, you can always skip it. But be careful, you don't want to skip too many points, especially if you're just generally trying to get an idea of what the line does. Now, I could technically just do -1, 0, and 1. You really only need 2 points to graph a line. If you are graphing it for a bigger intent, I recommend you do more. But if I just said, like, hey, graph this line, 2 points would be totally fine. So, in fact, I could stop here and be like, oh, there's my 2 points, done. But I'm going to be sassy and I'm going to go through the rest of them. All right. Now, if you can do some of these in your head, then you certainly don't have to do the math out. I'm just showing you how doing the math out works, so you know that I'm not just like creating magical numbers within my brain. All right, you'll also start to see a pattern here, and this is what makes it a line, okay? I said that it has a slope, and a slope is a rate of change, and in a line, a rate of change is constant. That's why when I graphed before, I could count up 1 and over 2, up 1 and over 2, up 1 and over 2 forever. Here, I can figure out how I got from -5 to -3.5, and that same difference, that same rate of change, will apply to the next point. So, to get from -2 to -1, I add 1. To get from -1 to 0, I add 1. Let me set my eraser down. Sorry, I only have 2 hands. To get from -5 to -3.5, double check my math. -5 plus 1 is -4, plus 0.5 is -3.5. Right? I'm at home, so sometimes my math brain doesn't work as well as it does at school. All right, -3.5 plus 1.5 is -2. So now, if I want the next point, 0 plus 1 is 1. -2 plus 1.5 is -0.5. Constant rate of change is what defines a line. It has that constant slope. So then if I wanted to find the next point, that'll give me 2, and then -0.5 plus 1.5 is 1. Okay, so that's another cool thing that you can really see in a T-chart that you can't see when you're doing your slope-intercept necessarily, unless you really stop and think like, oh, as I'm counting slope, it's because it's the same rate of change. You're going to see that awesome pattern where you have that constant change in y over the constant change in x. So my slope here technically would be 1.5 over 1, which is 3 over 2, which if you were that person at the beginning that was like, just divide by 2, dummy, that would have divided by 2. It would have given me 3/2 and then my -2, which is my intercept. Okay? So if I'm going to graph that, I'm going to go ahead and erase too much stuff. This part here, sorry, my board is old and it sort of holds its marker. But you know, needs must when the devil drives is something people have said before. Now, once again, I don't need every single point, so I might just go through and pick a couple of points, or maybe I'll be sassy and I'll start with the intercept. But because not every student is going to think to start with the intercept, I'm just going to go ahead and start with my first point, which was -2, -5. 1. So -2 in the x direction, -5 in the y direction. So remember that all ordered pairs are written to move in the x direction first, and then the y direction. Think of it as an address. This is your house number, this is your street address. So here's all the houses that have that same house number. Here's all the houses on that street. Where they cross at -2, -5 is your house number on your street. All right? So that's really what the ordered pair is. And if you are somebody watching this and you're like, oh, I could use some more help with ordered pairs, leave me a comment and I will do a video on graphing ordered pairs. I also have some interesting worksheets for that I can always upload to my classroom for those of you that actually have me right now as a teacher. Okay, what was I doing with my life? Graphing a line. -2, -5. Now, this one I might get a little scared of and I might skip it, this -1, -3.5. But remember, like for me, when you're graphing for me, I want you to be as precise as you can be, but like, I'm not going to look at it and be like, that looks like -3.45 instead of -3.5. So you just do your best. So I'm going to go -1, 1, 2, 3, and then about halfway between those two. Then I'm at 0, -2. Then I'm at 1, -1/2. And then I'm at 2, 1. And forgive my inability to draw a line. There is the graph of the line. Now this one also has a positive slope, but it's a different slope than the last line that we saw. The last way to graph is x and y intercepts, and that's one that I think I'm going to do as a separate video, because I think this video is probably already long enough. But I think that this has some good information, and I think I covered some good information. If you need actual physical hands-on help with graphing, like if this to watch me was not enough, that's okay. You can message me, all right? If you are any human and you need something from me, you can message me. Whether it's math related or not. So if you're my current student or an old student or whatever and you need something, message me. I think you can private message me on YouTube. I don't know, I've never done that before. You can leave a comment. You can email me. I'll save that one for later because I have school email and I have regular email and that might get chaotic. So graphing lines, I did Tchart, I did slope-intercept. I'll do a separate video for XY intercepts, but this is just kind of a nice review catch up. And I think it really showed you the idea of that slope is rate of change. I'll probably do a really fun one about word problems, because who doesn't love word problems? And yeah, I hope you have a good day, as good as you can have. I hope you are staying safe. I hope you are self-isolating as much as you can. And, I mean, I know it's not your first choice, but I would recommend you try some math out, okay? All right, so hopefully we'll be back in school in a couple weeks, and I'll see you then. Bye.